What's going on YouTube? This is Coach Carr here once again. Now, this video is on page 5 through 7 in your notes, and it focuses solely on Pythagorean Theorem. So I hope you enjoy. All right, so the learning target and success criteria. The learning target is to prove theorems about triangles once again, but success criteria is you'll be successful when you can solve Pythagorean theorem properly to solve for a missing side. All right, so the top of it has a little trivia question. It's asking who created Pythagorean theorem. Well, it was actually a Greek mathematician named Pythagoras. So when you get this right on a trivia night, you're welcome. And here's also a selfie of him as well. Okay, so at the top of page 5, it wants us to do an illustrator proof. An illustrator proof is just a proof that you actually just draw it out. So what we are trying to do is how do you prove a right triangle or prove a triangle is a right triangle using Pythagorean theorem. So the equation that we had used before in the video, the last video, was a squared plus b squared equals c squared. So if a squared plus b squared did in fact equal c squared, then I would have a right triangle. So if a squared plus this b squared would equal c squared, I would then get a right triangle. So a few things to make sure you know. The a and b can be interchangeable. I could have put the b here and the a here, did not matter, but what does matter is the c. C is always the hypotenuse. Okay, so for number 1 on page 5, it's wanting us to use Pythagorean theorem to find the length of the missing side of the triangle. So something that hopefully you notice when you're looking at it is this 5, they're saying it's the same length as this side here. So the length of this side of the triangle is 5, this part is 2, and then I'm trying to solve for x. So x is a cross from the right angle, so that must be my hypotenuse. So in case you forgot the equation we're going to use, it's a squared plus b squared equals c squared. So a and b, it does not matter which one I choose between the two legs. So I'll go ahead and do a squared as the 5. So I'm going to have 5 squared plus 2 squared equals c squared. And we kept it as c because I don't know the hypotenuse. That's what I'm trying to find. So 5 squared, so 5 times 5 is 25. 2 squared is 4. And this equals c squared. So now I want to add them together, and I get 29. So 29 equals c squared. Well, I do not want to keep it as c squared. I want to get the c by itself. So the way that we get rid of a square is through a square root. So I'm going to have the square root of 29 equals c. And when I do that, what I get is 5.38516. Now I just kept my decimal going for a while because it didn't tell me where to stop at. So that would be my answer. So that equals C. Or in this case, if you want to keep it the same variable, I would have 5.38516 equals X. So that is my answer. Okay, so now we're on number 2 on that same page. It says, given the triangle and its perpendicular bisector, find the area of the triangle. Write the answer in exact and decimal form. So first thing that they tell us that's important is that we have a perpendicular bisector. So this line going down, which I could also call an altitude because it starts at a vertex, goes down and makes a 90-degree angle, is a perpendicular bisector. So perpendicular tells us that we have the right angle, which they already drew in there for us. The bisector part tells us that each of the sides must be equal to each other. So if that's the case, if the full length is 10, that means each portion must be 5. That's what that's telling us. Now, the other thing we need to know is what the formula is for the area of a triangle. So, in case you don't remember that, that is base times height over 2. So that's the area of a triangle. So from this problem, those are the two main things that we needed to know right away. Okay, so in order to find the base, we actually already have that. The base of this full triangle is down here, which is 10. The height is what we actually need to find. So we're needing to find this height right here. And the way we're going to do that is through Pythagorean Theorem. So in case you already forgot Pythagorean Theorem, it's our a squared plus b squared equals c squared, where a and b are the legs and c is the hypotenuse. So I'm going to look at just one side of it to find this height, because that makes it so I have a right triangle. And you can only use Pythagorean Theorem when you have a right triangle. So for instead of a squared, I'm going to make it 5 squared. Now, I don't know the height of the leg. That's what I'm looking for. So I'm going to keep that as b squared. But the c, I already know what my hypotenuse is going to be. So it's going to be 7 squared. So now, do my squaring. 5 squared is 25, plus b squared, because I don't know what it is. And then 7 squared is 49. Now, we want to subtract 25 from both sides because we're trying to get b by itself. And when I do that, I get b squared equals 24. And now I want to get rid of the square. So what you would have now is b equals the square root of 24. And now what I shall do is do it in two different ways, since they want the exact and decimal form. So the exact way to get the square root of 24 is doing a little like tree. So figuring out what can multiply into it. So if I were to do that, I could do, let's say, 6 times 4. Now both of those numbers can be broken down again. So now I have 2 times 2 and 3 times 2. So what you need to do is look for your pairs. So is there any numbers that have a pair with it? Well, we have a pair of 2's here, and then the 3 and the 2 can't be paired up together. So whatever you find a pair of, that goes outside of the square root symbol. So what I would have is, I'm going to continue it up here, 2, because that's what I took out, because that's my pair. And then whatever's still left inside stays inside. So 3 times 2 gets me 6. So 2 square root of 6 is this right here. Now, that would be the exact form of finding this square root. The other way was to do it with decimal form. So if I just did the square root of 24, I would get 4.898979. Let's say if I just wanted to round to the 10th, so one decimal place, I would get 4.9. So between the two ways of getting the square root of 24, these are a couple ways that I could have that. All right, so we're not done yet though. So we found what this length is in both forms. So now we're going to find the area of the triangle, and we're going to have two answers which are technically the same answers, just one's in the exact form, one's in decimal form. So again, to find the area of a triangle is that base times height over 2. So first I'm going to go ahead and do it in decimal form. So the base is 10. So that's the full length, that's the base, times our height of 4.9 all over 2. So what I would have is 49 over 2. Divide that and I get 24.5 meters squared. And we make it as meters squared because we're talking about area. Now, the next one we want, I'm going to do an exact form. In exact form, this is where we use this one here, that 2 radical 6. So, again, our base is 10. That's times our height, which is 2 radical 6 over 2. So when you multiply these, I can only multiply the numbers that's outside of the radical. So 10 multiplies with a 2, that gets me 20. So I have 20 radical 6 in the numerator, all divided by 2. When I go to divide it, when you're dealing with radicals, I can only divide what's not inside the radical. So I can do 20 divided by 2, and that gets me 10. So my answer in exact form would be 10 radical 6. All right, so on the bottom of this page it says, is it right, acute, or an obtuse triangle? These are all the equations that help you know what kind of triangle it actually is. So these are the things, so if the c squared, the longest side, is less than whatever a squared plus b squared is, it's acute. If the longest side is greater than whatever a squared plus b squared is, so the two legs, it would be obtuse. And if the c squared is equal to a squared plus b squared, then it's a right triangle. So the main thing I want you to know is that A and B, they are legs. So those are two of the sides of a triangle, so the two smaller sides of the triangle. And C is always the longest side. Now, if it's a right triangle, it's called a hypotenuse. If it ends up not being an acute or an obtuse angle, it's just the longest side of the triangle. All right, so now we're on page 6 and looking at number 5. So we have gone over the basics of Pythagorean Theorem. Now we're going to actually use it in real-world situations. So it says, Joey won a new flat-screen TV with integrated speakers in a school raffle. The outside dimensions are 33.5 inches high and 59 inches wide. Each speaker located on the sides of the screen measure 4.5 inches in width. TV sizes are determined by the length of the diagonal of the screen. Find the size of the TV showing all supporting work. Round your answer to the nearest inch. Okay, so in order to find the length of this TV, they said that it's done by looking at the diagonal. So the diagonal is going from this portion of the screen to this portion of the screen. Now, this is in the shape of a rectangle. So if it's in the shape of a rectangle, that means all the angles are 90 degrees. So we are actually, by doing this diagonal, making a right triangle. So that's why we're going to be able to use Pythagorean Theorem. Now, to find this length here, we only want to look at the screen. We don't care about the speakers to find out the size of this TV. So what we're wanting to do is break it up. So this portion is 4.5. This portion is 4.5. So what you're doing is, if I take both of these portions, 4.5 plus 4.5 is 9. I am actually doing 59 minus 9. So the full length minus these speakers, which would get me 50. So the length I'm actually dealing with here is 50 inches. So the length that I care about is 50 inches. The side is still going to be whatever they just told us, the 33.5 inches. So this side is 33.5 inches. So we have these two sides of the right triangle. We just need to find the hypotenuse, which is the longest side in a right triangle. So we can use Pythagorean Theorem. So Pythagorean Theorem is the a squared plus b squared equals c squared. So again, a and b are the legs. So it doesn't matter which one I make a and which one I make b. So I'm going to make it so we have 50 squared plus 33.5 squared equals c squared. Because again, we're trying to find the hypotenuse. We're trying to figure out how big this TV is. So 50 squared is 2,500. 33.5 squared is 1,122.25. And this is all equal to c squared. Now I want to add these together. When I do that, I get 3,622.25 equals c squared. Now I don't want it to be squared, so the way you get rid of a square is through a square root. So I have the square root of 3,622.25 equals c. And when I do that, I get 60.18513. Now, the last part I need to remember was it said round your answer to the nearest inch. So if I'm rounding to the nearest inch, I'm rounding to the nearest whole number. So this 0 is the only thing that could potentially change, but since the number next to it is a 1, it's not going to get any bigger because it has to be 5 or higher for it to round up. So this is a 60-inch TV. Okay, so the last problem on this video is going to be number 7 on page 7. It says Mr. Peabody wants to hang holiday lights from the roof on the front of his house. His house is 24 feet wide, 35 feet tall at its highest point. The lowest point of his roof is 24 feet off the ground. What is the total length of lights you will need to purchase? Show all of your calculations and round your answer to the nearest foot. So luckily they were nice enough to draw and label most of the stuff. Now they tell us that the only place we're going to be putting lights is on these two spots. So he's only going to do it there and there. The height of his house is 24 feet. The full length, if I went from the bottom to the top, is 35 feet. So I am actually going to, because I want to deal with a right triangle, I'm going to be drawing a line straight down. So it's going to create a perpendicular bisector. Now, since I know this part is 24 feet, but the full thing from the roof all the way down is 35 feet, what I can actually do is subtract the two numbers. So 35 minus 24 would give me 11. So that is how I got that one there. Now, earlier I said this would be a perpendicular bisector. So that means this portion and this portion would have to be congruent. if that's the case and the full length is 24, that means each side must equal 12. Now that we have some lengths for this triangle, we're going to be able to find the length of where our lights are going to be because they're our hypotenuse. So we're going to use the formula that we, for Pythagorean Theorem, our a squared plus b squared equals c squared. And for a, I'm going to go ahead and use 11. For b, I'm going to use the 12. And c squared is what I'm trying to actually solve for. Now here, 11 squared is 121. 12 squared is 144. And that equals c squared. Now I want to add them together. So that would be 265 equals c squared. Now I want to get rid of the square, so the way that we do that is through square rooting it. So the square root of 265 will be what c equals. And that's going to get me 16.2788 equals c. Now, earlier they said round your answer to the nearest foot. So if I am doing that, I need to be rounding it to the nearest whole number. So the only thing that could potentially change is the 6. So I have to look at the number next to it. It's a 2. So it's not bigger than 5, so I am not going to round up. So it is, each side would be 16 feet. So each side is 16. If I want to know the total length of lights that I want, so he only wants to do it here and here. Now I would just do 16 plus 16. So 16 plus 16. And that would mean that I would need 32 feet of lights. Thank you once again for watching. That's the end of this video. Make sure that you do exit ticket number 3 and 4. So, but besides that, make sure that you also like, subscribe, ring that bell, and once I get merch, make sure you buy it.